Hello friends, I welcome you all in the world of mathematics. I am Atul Kumar, your maths faculty. Here I am going to discuss with you a question from limit. The approach is rather different. I have used L hospital rules for doing the same question. I have used series expansion for doing the same question. But here I have used concept of inverse trigonometric function in doing this question. Okay, so let's see. X tends to 0 limit sine inverse x minus tan inverse x upon x cube. Okay, so let's start like this. Suppose sine inverse x is theta, therefore sine theta is x, and tan theta is x upon 1 upon x square, because perpendicular is x, hypotenuse is 1, base is under root 1 minus x square, right? It is very simple. So tan theta is x, then sine theta is x, then tan theta is x upon under root 1 minus x square. Okay. Therefore, theta can be written as tan inverse of x upon under root 1 minus x square, and hence sine inverse x is converted into tan inverse x, in tan inverse of x upon 1 minus x square under root. Now sine inverse x minus tan inverse x. We have just put the value, and we know the formula sine inverse tan inverse A minus tan inverse B. Okay, tan inverse A minus tan inverse B. How much? It is tan inverse of A minus B divided by 1 plus AB. Using the same formula, here we get tan inverse of this much. Come to the next slide. We have simplified tan inverse of this. Here we have just rationalize this. 1 minus under root 1 minus 1 minus under root 1 minus x square. So we have multiplied and divided the numerator. We have multiplied the numerator by 1 plus under root 1 minus x square, and also the denominator by the same thing. So using a plus b, a minus b into a plus b is equal to a square minus b square. So if I multiply by 1 plus under root 1 minus x square, the numerator becomes 1 minus 1 plus x square by this formula. Okay, this 1 and 1 is cancelled here, and ultimately it is x cube, tan inverse of x cube divided by under root 1 minus x square plus x square into 1 plus under root 1 minus x square. Let us call this thing, this expression in x as phi x. Okay, so the next slide. So our required limit now becomes, this is our required limit, and this becomes x tends to 0 tan inverse of phi x by x cube. This can be rearranged by limit law, like x tends to 0 tan inverse of phi x by phi x into x tends to 0 limit phi x by x cube. But as you can recall, phi x is this much, right? So as x tends to 0, obviously phi x will tend to 0, and therefore since x tends to 0, phi x tends to 0, therefore x tends to 0 tan inverse phi x by phi x is 1, a standard limit. Theta tends to 0 limit tan inverse theta by theta is 1, right? Like this. Now by the expression phi, if phi is this much here, uh, 5 by x cube is what? 5 by x cube is 1 upon under root 1 minus x square plus x square into 1 plus under root 1 minus x square. As x tends to 0, this expression will become 1 upon 1 into 2, that is 1 by 2. So let it be b and let it be c. Using b and c in a, what will be our required limit? Our required limit L will be 1 by 2. Okay, so this is the required limit. So this question is solved here by using inverse trigonometric function, the concept of inverse trigonometric functions, particularly the formula tan inverse A minus tan inverse B, and before that we have converted sine inverse x in terms of tan inverse. Okay, so here we have seen that one question can be approached in many ways, and it is always beneficial to know more than one method. It aids in our concept. Okay, it increases our confidence in doing the question. Okay, thank you very much. I hope you enjoyed this solution.